Hello, my name is Stuart Taggart. I am the principal of Grenatec. We're a research organization studying the viability of a pan-Asian energy infrastructure. The vision is big and exciting. This video covers one part of the vision.
Sorry that I can't be there in person. If we can get a Skype connection working, I may be able to take questions. If we can't, I can communicate with any of you by email. My address is at the bottom here. Apologies for the sound quality. I'm on the road and I don't have access to a quality microphone. Given this, I'll run a transcription in case the audio is impossible to understand. Now, let's get started. Grenatec is a non-profit research organization studying the viability of a pan-Asian energy infrastructure. Grenatec has developed the most comprehensive plan to date of how such a network might eventuate. Our concepts are grounded in existing ideas. In this talk, we'll look at some of these and how they might be starting to sketch out a very exciting future. We'll begin with some mainstream views. Number one, if the world is to have any hope of reducing destructive climate change, the world must completely replace its business-as-usual energy infrastructure with something better. This from the International Energy Agency. Number two, better infrastructure benefits everyone, according to the Asian Development Bank. Nothing controversial there. Number three, an undersea energy link between Australia and Indonesia is inevitable. This, according to global infrastructure giant Siemens. Number four, Australia could develop so much large-scale concentrating solar power in its desert outback that it could export that solar energy northward to Indonesia and beyond. This, also from the International Energy Agency. In the next few minutes, we're going to examine where these four premises can take us. Grenatec has developed a topology for a pan-Asian energy infrastructure. This would stretch roughly 13,000 kilometers from Australia to China, Japan, and South Korea. Grenatec outlines this topology in detail in 3 reports available free from our website. They are Pan-Asian Energy Infrastructure, the East China Sea, and the South China Sea. The first report covers all of Asia. The other 2 reports cover important subregions. In 2011, Grenatec published peer-reviewed research in a special proceedings of the Institute of Electrical and Electronics Engineers. Grenatec's research spans all of Asia. But here, we'll focus on Indonesia, East Timor, and Australia. These 3 countries would be the southern anchor of a pan-Asian energy infrastructure. At Grenatec, we believe Asia's emerging energy and data infrastructure is showing signs of intelligent design. The challenge is to recognize this emerging pattern and build on it. Specifically, this means bundling power lines, gas pipelines, and fiber optic cables. Let's examine some examples. In China, State Grid is developing ultra-high voltage direct current power line technology. This is high-capacity, low-loss, long-distance electricity transport technology. Has already built 2 regular HVDC lines in China. Up to 24 more are planned. Some of these will be UHVDC. At the same time, China is building out a domestic natural gas pipeline transportation and distribution network. China also is linking its cities together with fiber optics. Meanwhile, the Association of Southeast Asian Nation-States has developed plans to deepen its cross-border energy links. This through the Trans-ASEAN Gas Pipeline and Trans-ASEAN Electricity Grid projects. Finally, Australia is building up a natural gas export capacity using liquid natural gas technology. Australia also is wiring the country with fiber optic cable to create a national broadband network. Put it all together, and a pattern of intelligent design emerges. The key now is for the natural gas guys, the electricity guys, and the fiber optics guys to get to know each other better. The reason is that they have a lot in common. These 3 industries, gas, electricity, and data, could all save money by working together, building infrastructure, and sharing costs. Now, let's talk about Australia, East Timor, and Indonesia. Australia has huge amounts of solar energy it can generate in its sunny outback. A concentrating solar power plant, roughly 1,000 kilometers on a side, could satisfy all of humanity's electricity needs. Australia also has wind, geothermal, biomass, tidal, and wave energy. What Australia needs, of course, is the will and the infrastructure to develop this energy and transport it to countries like China, Japan, and South Korea, like Siemens and the IEA suggest. For this to happen, Australia needs to build out its domestic electricity grid. Swiss electricity cable multinational ABB has suggested some routes. Grenatec has taken these and other existing ideas, plus a few of our own, and bundled these together. The result is a proposed continent-spanning infrastructure for electricity, natural gas, and telecommunications. At this point, the problem becomes Indonesia and East Timor. Indonesia's large-scale national electricity grid pretty much stops at the eastern end of Java. To connect it to Australia, it would need to be extended across the eastern archipelago and across the island of Timor as well. As it happens, this path is already being blazed by Indonesia's telecommunications guys. Under the Pelopor Ring project, Indonesia is laying subsea fiber optic cables across its entire eastern island chain, all the way to West Papua. Indonesia's telecommunications company, PLN, which is building the system, is willing to extend it to Dili and Darwin, if East Timor and Australia are willing. If Indonesia's Pelopor Ring reached Darwin, it could interconnect with Australia's national broadband network. Taken together, this sketches the southern outline of a pan-Asian energy infrastructure that natural gas pipelines and high-capacity power lines could then parallel. Let's move on to the linchpin, natural gas. Grenatec believes the gas industry holds the key to a long-term, wealth-creating energy revolution in Asia based upon harnessing market efficiency. We'll even go a step further. The decisions taken by Asia's natural gas industry may well determine what life is like for all of mankind in the second half of the 21st century. The reason is that Asia is expanding economically as millions climb out of poverty and the region becomes the world's largest economic bloc. Asia already produces 20% of global greenhouse gas emissions. Business as usual could make that percentage rise to 40% or more by 2050. That would virtually eliminate any hope of preventing very destructive climate change. Remember what the IEA said about the needed total turnover of energy infrastructure? Well, much of Asia has nothing to turn over. It's building a lot of infrastructure for the first time. Building it the old-fashioned way, using outdated technologies, is environmentally suboptimal and just plain dumb. Asia can leap ahead to new technologies instead of building obsolete ones that will have to be replaced. Take liquid natural gas. Right now, Australia is building hundreds of billions of dollars of LNG infrastructure to ship highly compressed natural gas to China, Japan, and South Korea. But LNG has drawbacks. The biggest of these is that LNG is greenhouse gas intensive. This takes Asia backwards in battling climate change. LNG is also a short-lived, inflexible technology, and this is creating civil society controversy. In Queensland, for instance, UNESCO may soon label the Great Barrier Reef as endangered due to environmentally destructive LNG development. In Western Australia, civil society opposition forced Woodside to scuttle a proposed LNG plant at James Price Point, north of Broome. In the Timor Sea, differences over LNG development between Woodside and East Timor are holding up development of the Sunrise Field. Instead of LNG, what Asia needs is a flexible, future-proof, regional gas transport system that can outlast natural gas. Where this leads is to pipelines. Pipelines can carry natural gas, but they can also carry other things like hydrogen, biofuels, and even waste carbon. They already do all of this in Canada, the United States, and Europe. In 2005, Australian gas major Santos argued that Australia's unconnected East Coast and West Coast natural gas pipeline systems should be connected for efficiency's sake. Santos also argued that such an interconnected pipeline network should also stretch all the way across the Timor Sea to East Timor. 7 years later, a Timor Sea gas pipeline is exactly what East Timor has in mind. If Australia followed Santos's advice, and East Timor insisted upon pipelines from Sunrise to its territory, and the ASEAN states are deepening gas network interconnections, and China is building out its natural gas network, a pattern of intelligent design begins to emerge in regional gas transport. Interconnecting all of these bits would create a network that could last a century or more. A Pan-Asian gas pipeline could carry natural gas today and biofuels, hydrogen, and even waste carbon tomorrow. The key is flexibility. The decisions made by Asia's natural gas industry in coming years are critical for the future global battle against climate change. And East Timor's decision over Sunrise has huge implications for Asia's natural gas development. In other words, East Timor holds some very important cards for the future of Asia. The reason is that if natural gas pipelines were built paralleling the fiber optic systems Australia and Indonesia are now building, HVDC cables would be next. At that point, the overall bundled network would be complete. The biggest hurdles to building a Pan-Asian energy infrastructure. Without a doubt, it would be the stretch separating the Sunrise and Bayu Undan fields and East Timor's south coast, and the stretch of the Sabu Sea separating Dili from Indonesia's Alor Island. Each would involve crossing sea areas with depths of greater than 2,000 meters. Impossible? Hardly. Start with HVDC. An HVDC cable connecting Sardinia to mainland Italy lies in roughly 1,600 meters of water. As best I know, that's the deepest one in existence. However, I've been assured by ABB and others that there's no technical reason HVDC cables can't be laid deeper. It just hasn't been done yet. Natural gas pipelines, by contrast, have been laid that deep. New pipelines would go even deeper. For instance, the proposed White Stream pipeline planned for the Black Sea would be laid at depths of 2,000 meters, and the proposed SAGE pipeline between Oman and India would be laid in roughly 3,000 meters of water. It should also be added that two long-distance subsea gas pipelines are already operating in Europe. These are the Langeled pipeline between Norway and the UK and the Nord Stream pipeline between Russia and Germany. Both are more than 1,100 kilometers long. A bigger issue in Asia would be potential tectonic activity. Yes, the northern Timor Sea and the Sabu Sea are affected by earthquakes. Perth-based Incitec Engineering, in a study for East Timor, found that most earthquakes in the Timor Sea occur deep in the earth and are moderate, generally around 5 on the Richter scale. To put this into some perspective, 5 on the Richter scale is roughly the same risk as on Bangka Island just south of Singapore. There, Indonesia has proposed building 2 nuclear plants. So, how to move forward? Well, the Australian gas industry is a bit on the back foot right now. LNG project prices are rising astronomically. LNG projects are also proving controversial with local communities. And no one's that enthusiastic about floating LNG. Our view is that this is intelligent design at work. We believe that Asia will, through fits, starts, and messy protests, eventually realize the compelling logic of bundled, future-proof infrastructure. And this will be part of the total turnover the IEA says is necessary to battle climate change. So, how to get from here to there? Organizations like the ASEAN Plus groupings and/or the Energy Charter Treaty are good places to start hashing these issues out. There are other forums as well. At Grenatec, we believe a Pan-Asian energy infrastructure should operationally be managed from Singapore. As a small fish sandwiched between larger economies, managing the network from Singapore allows ASEAN to punch at an equal weight to its bigger partners China, Japan, South Korea, and Australia. In terms of infrastructure, China State Grid would probably be the default supplier of high-voltage power lines. State Grid already is running and upgrading the Philippine electricity grid under a 25-year contract. State Grid also recently bought in to South Australia's electricity grid. Gas pipelines have any number of suppliers. So do fiber optic cables. The benefits of bundling are huge. They will increase efficiency, supply security, fuel switching, the role of markets, and perhaps most of all, provide a multilateral means of handling emerging geopolitical tensions in the South China Sea and the East China Sea. The reason is that everyone will be drinking from the same water hole. Cooperation will be in everyone's interests. All of this has been a very quick run-through of the Pan-Asian energy infrastructure ideas as they relate to Australia, East Timor, and Indonesia. Together, the three could make a major contribution to reducing destructive climate change. They could do so through building more efficient, long-lasting, flexible energy infrastructure that will be viewed, in hindsight, as visionary in 100 years' time. There's precedent here. The UK-Australia telegraph. Built despite naysayers and with a few false starts, the telegraph system was built virtually along the same routes as a Pan-Asian energy infrastructure. Today, we marvel at the intellectual foresight and courage of the hemisphere-spanning telegraph systems, designers, and builders. It's time to think big once again.